Hi class, this is course 3, lesson 37. We are talking about areas of combined polygons. And so we're going to look at just four examples today where we're dividing the figure into smaller parts. Okay, so we know the formula, area of a square is the side cubed. Area of a rectangle is length times width, and this is just to remember. Area of a triangle is 1/2 the base times the height. Okay, so we know those formulas and we can use those to find the area of trapezoids and complex figures. Okay, so here's a trapezoid. I'm going to start dividing this and calculating the area. Okay, so I know if I draw a line right here that it's going to be perpendicular, so I know that this is a rectangle, so I can do the area of the rectangle, and I can find the area of the triangle and add them together to get the area of the trapezoid or the quadrilateral. So the rectangle would be the dimensions. If I draw it out like this, we have 6 by 3, and using my formula I would take 6 times 3, and that would be 18. The label is inches, so it's inches squared. The area of this triangle, now in order to do that I need to label some dimensions here. So this horizontal piece here would be 6, and then I have to figure out the length here. So notice that this is 6 inches and this was 3, so this has to be 3. So I have a triangle. If I draw it like this, I have 6 and 3. So I would take 1/2 times 6 times 3, and I would end up with 9 inches squared. Now, I'm not done because that was 18 inches here and squared, and this is 9 inches squared here, so I need to add those two together, and I get 27 inches squared. Okay, so there's one example. Here's another one. Copy this down into your notes. You can press pause and then resume when you're ready. I'm just going to get started. Okay, the first thing that I notice is, so we're going to calculate area. Let me write that down for you. Is that I have a rectangle and I have 4 triangles. So if I just calculate the area of all those different pieces and add them all up, I'll get the area of all these shapes combined. So let's take a look at a small triangle that has a bottom dimension of 1 and a top dimension of 2. So if I use that formula, 1/2 times 2 times 1, I get 1 meter squared. Now I have 2 of those, right? So I did this one, and I have this one to do, so I can just write that down again. This rectangle is 3 by 2, which is 2 times 3 or 3 times 2, which is 6 meters squared. So that's done. And then I have this triangle up here that I can do all at once. I don't have to do the individual sides. I know the height and I know the base because this is the same up here as it is down here, so it's 3. So that large triangle is going to be 1/2 your base, which is 3, times your height, which is 3. So 1/2 times 3 times 3, so what's 1/2 of 9 would be 4.5 meters squared. Add these all up together. You get 4, 10, 11, 12.5 meters squared. Now, let me show you. This one happens to be, this is a triangle. And if I can draw this, I can continue that height in my small triangle all the way down to the bottom. Then my height is 3 plus 2. 3 plus 2 is 5. That'd be my height. And then this dimension would be 3, 4, 5. So it'd be 1/2 the base, 5, times the height, 5, which is 1/2 of 25, which is 12.5 meters squared. Okay, so there might be multiple ways that you could do this problem in order to get the same answer. So just use some critical thinking and you'll get there. So 2 more examples. Little cat's face, right? Little cat ears here. So they have this already divided into a triangle and part of a rectangle. You can see that if you draw a line here, that you get, since this is 6 on the bottom and this is 3, that this is 3 here. So these would be the same size. Now, that doesn't mean that they're always going to be the same size. So be very careful when you look at and evaluate what those missing dimensions are. So I have 2 triangles that are the same. So the area of one of those triangles would be 1/2 base 3 times 7. So this is 1/2 equals 1/2 of 21, which would be 10.5. Okay, now how many of those do I have? I have 2 of those. So if I'm going to multiply this by 2 again, I just divided it by 2. If I multiply it by 2, I'm going to get 21 right back. So the multiplying the 2 undoes the dividing by 2. So then all you're left with is your rectangle, which is 6 by 3. So 6 times 3 is 18 centimeters squared, and you have to add them to get the combined area, and you'd end up with 39 centimeters squared. Okay, lastly, you're going to see problems like this, and they want you to find the area of the quadrilateral. Okay, so I have a large triangle, a quadrilateral, and I have a small triangle. Now, the trick to these problems is this. If you were to separate these into a large triangle and a small triangle, you know that this angle is the same. You know that this angle is the same because they shared it. And so you know that this angle is the same as well. There's only one way to make that work. So we have similar triangles. And where we have similar triangles, we have side lengths that are proportional. So if I find the side length of the large triangle, which would be 40, and I know the side length of the large the large triangle would be 50. I can find this missing side length here. Okay, now you don't need that to find the area. You need that to find the perimeter, and you're going to have to do those problems as well. Okay, if you were to find the area of, or define the area of the quadrilateral of this, you would find this area and subtract that small triangle from it. So the area would be 1/2 30 times 40, because that's your base and your height, minus 1/2 20, well, I guess you do need that to get your height, 20 times what? Okay, so we need to know what that is. So I'm going to switch colors here, and we're going to work on the similar triangles. Okay, we can write ratios, right? The side lengths have to be proportional. So 30, the short side of the big triangle over the missing side, has to be the same proportion as, and you can pick either of the other sides. Maybe the hypotenuse, 30 is the big triangle, so we need the big triangle hypotenuse over the small triangle hypotenuse. Okay, and remember, if you can't go side to side, you can go up and down. So this would be divide that by 2. Divide by 2. So I would have to take 30 divided by 2 to get my x value. So x has to be 15. So I now know that this side length is 15, and this up here is 15 as well. So I can plug that in there. Now I can find the area of that quadrilateral piece. So 1/2, 30 times 40, let's see, if I divide that here, I'd get 600 minus, that would be 10, 600 minus 150, so 600 minus 150 would be 0.565, 450, and then label that appropriately, centimeters squared. To calculate the perimeter, you would just add up these dimensions. So you'd have perimeter would equal 30 plus 20 plus 15 plus 25, giving you 30, 40, 50, 60, 70, 80, 90 centimeters. Okay, that's it for finding combined, or the area of combined polygons. This piece right here, the similar triangle piece, might be something that you struggle with a little bit, so make sure that you ask. Also, make sure when you're labeling area, it's always in square units. Okay? I'll see you in class.